Hello and welcome back to Tech Eureka TV, your go-to channel for fascinating insights into the world of science and technology. Today, we're embarking on a journey to the edge of understanding, as we explore the theory of the universe's boundaries. First, let's talk about the shape of the universe. Is it a never-ending flat plane, a giant cosmic sphere, or something entirely different? The most widely accepted theory, based on observations from the Planck spacecraft, suggests that the universe is flat and infinite. But what does that mean? Well, if you were to travel in a straight line across the universe, you would never return to your starting point, and there would be no discernible edges or boundaries. This idea is based on the cosmological principle. It's a principle that brings a sense of order and simplicity to our understanding of the universe. But what does it really mean? The cosmological principle states that the universe, when observed on a large enough scale, appears homogeneous and isotropic. Homogeneous means that the universe is the same at every location, it has a uniform density. Isotropic means that the universe looks the same in all directions, it has a uniform appearance. Imagine standing in an endless field of wheat. No matter where you stand in the field, and no matter which direction you look, the view is essentially the same, wheat everywhere. This is a simple way to visualize the homogeneity and isotropy of the universe. But why do we believe in the cosmological principle? The main reason is observational evidence. When we look at the cosmic microwave background radiation, the afterglow of the Big Bang, we see that it's almost perfectly uniform across the sky. This suggests that the early universe was incredibly homogeneous and isotropic, and it's believed that the universe has maintained this uniformity as it has evolved. Another important concept when discussing the universe's boundaries is the Friedmann-Lemaitre-Robertson-Walker metric, or FLRW metric. This is a mathematical model that describes a homogeneous and isotropic universe. But what does this mean, and why is it important? In the context of the FLRW metric, homogeneous means that the universe is the same at every point, and isotropic means that the universe looks the same in all directions. This is a mathematical way of expressing the cosmological principle, which we discussed earlier. The FLRW metric is derived from Einstein's field equations, the core of his theory of general relativity. These equations describe how matter and energy in the universe influence the curvature of space-time, and vice versa. The FLRW metric is a solution to these equations that assumes the universe is expanding or contracting uniformly. The FLRW metric is crucial in our understanding of the universe's evolution and structure. It forms the backbone of the Big Bang theory and the lambda CDM model, which is the current standard model of cosmology. According to this model, the universe began in a hot, dense state and has been expanding and cooling ever since. The topology, or the shape without the size, of the universe is another fascinating area of study. Topology, in the broadest sense, is the study of the properties of space that are preserved under continuous transformations. In other words, it's about the shape of space, but not its size. When we talk about the topology of the universe, we're asking questions about the fundamental structure and nature of the space that makes up our universe. The universe could be simply connected, like a sheet of paper. This means that any loop you can draw in the universe can be continuously shrunk down to a point without leaving the universe. In a simply connected universe, if you set off in a spaceship and travel in a straight line, you would never return to your starting point, assuming the universe is infinite. On the other hand, the universe could be multiply connected, like a donut, or torus. In a multiply connected universe, there are loops that cannot be shrunk down to a point. If you were to travel in a straight line in such a universe, you might eventually return to your starting point, having circumnavigated the universe much like one can circumnavigate the Earth. The shape and topology of the universe have profound implications for the Big Bang and for the universe's ultimate fate. For example, a multiply connected universe could have originated from a different type of Big Bang singularity than a simply connected universe. The topology could also affect the universe's expansion and the distribution of galaxies. Speaking of fate, what does the shape and boundary of the universe tell us about its future? If the universe is closed, meaning it has a positive curvature like a sphere, it could eventually stop expanding and start contracting under its own gravity. This could lead to a scenario known as the Big Crunch. In a Big Crunch, the universe would collapse in on itself, potentially ending in a singularity, a point of infinite density. This would be a kind of reverse Big Bang, with galaxies, stars, and all matter rushing back towards a central point. On the other hand, if the universe is open or flat, meaning it has a negative curvature or no curvature, it could continue expanding forever. This could lead to a scenario known as the Big Freeze or heat death. In this scenario, as the universe expands, it cools down. Stars would eventually burn out, galaxies would drift apart, and all processes that consume energy, such as life and computation, would cease. The universe would become a cold, dark, and desolate place. There's also a third possibility, known as the Big Rip. If the universe contains enough dark energy, a mysterious form of energy that is causing the universe's expansion to accelerate, it could end up tearing itself apart. In this scenario, galaxies, stars, planets, and even atoms could be ripped apart by the ever-increasing expansion of the universe. So, there you have it. The theory of the universe's boundaries is a complex and fascinating topic, filled with mind-bending concepts and profound implications. While we may not have all the answers yet, one thing is for sure, the universe is a far more fascinating place than we could ever have imagined. Thank you for joining us on this cosmic journey. Don't forget to like, share, and subscribe to Tech Eureka TV for more exciting insights into the world of science and technology. Until next time, keep exploring.